Today we're going to talk about function notation, and before we really get into the function notation, I just want to remind us of a couple of definitions that we talked about in our previous notes. We started off with a relation, which is any set of ordered pairs. As part of ordered pairs, we have an x value and a y value. And the x value is called the domain, and it's the input of the function. It's also the independent variable. The y value is called the range, and it's the dependent variable, and it's also the output. So that's from previous notes. So as we take a look at this, functions are tools that convert inputs. So there's our x values, which are also known as independent variables, to outputs. There's our range, there's our y values, there's our dependent variable. And there's a special notation, which we use to represent this process, and it's down here in the box. It says function notation, and then it says y equals f parentheses x. That is read as y equals f of x. And the x in that is the input, the y is the output. The x is the domain, the y is the range. Function notation, what I often like to say is that f of x is just another way of writing y. That's all that it is. But oftentimes we see something that looks like this in the box, and it doesn't really make any sense until we put some numbers to it. So if we look at our first example here, evaluate each of the following given the function definitions and the input values. Well, remember what this is when we're looking at this. It says f parentheses 3, that is an f of x. So 3 is the x value, and what this means is we're going to take this value of 3. We're going to put it back into our function wherever we see x. So this is going to become 5. Instead of writing x, we're going to put 3. We put that in input minus 2. And then we do the math. 5 times 3 is 15 minus 2, and 15 minus 2 is 13. 13 is our output. It is the y value of the function. And it doesn't matter what we are using here. The nice thing is that we call this function f because it says f parentheses x. So we can give multiple values of x to help us come up with this problem. In other words, what I'm trying to say here is we can take this value of -2 and we can put it back into our function wherever we see x. It's another input, and in this case what it would be is going to be 5. Instead of writing x, this time we're going to put in -2 minus 2, and then we can do the math. And feel free to use your calculator if you need to. 5 times -2 is -10 minus 2, and our output is -12. X, -2, input. Y, -12, output. A couple more examples here. We have g of x. Well, g of x is just like f of x, only this time we called it g. So it's the name of the function. In our first situation here, this time what we've got is we've got 6 for our input. So wherever we see x back in our equation, we're going to replace it with 6 in this case. So this is going to become 6 squared plus 4. And if you need to, type it in your calculator and remember that squared means times itself. So 6 squared is 36 plus 4, which equals 40. But we're not limited to only one input. Our next value underneath there on your notes says g of -1. I'll slide it up here, but the process is still the same. This time our input is -1, so we're going to replace the x in our g function with -1. So this time it's going to become -1 squared plus 4. And I am going to use my calculator on this one. I just want to remind you that when you type in a squared value, you're really better off if you have parentheses. -1 squared, which is 1. And you could have done the plus 4, but watch out. It's 1 plus 4 equals 5. Watch out with that negative being squared. The parentheses is really important. -1 is our input. That's what we put into the function for x. And the 5 is what we got out of it. The -1, we were allowed to pick anything. We picked 6 first, and then we picked -1. But once we determine the outcome, that's the dependent. Whatever we pick for x helps us determine what we get for y. Letter C. H of x equals 3x. Square root of 3x. And if we look at this one, h of x, once again, it's another way of describing a function, but it's h of 5. 5 is the input. So we're going to put the 5 back into our function wherever we see x. So this is going to become 3 times 5. And we can simplify that just slightly, because 3 times 5 is 15. It's the square root of 15 when we look at this function altogether. 5 is the input. The square root of 15 is the output. 5 is the x. The square root of 15 is the y. Same idea over here with h of 0. 0 is the input, but when we put this 0 back in, it's going to be 3 times 0, and we can simplify just a slight bit more. 3 times 0 is 0, and believe it or not, we can take the square root of 0, whereas we could not take the square root of 15. If you're unsure, pull out your calculator, second, and then the x squared button gets you up to the square root button, and 0, and enter. Will give us the value of 0. So long-winded way of illustrating input and output, domain and range, independent and dependent variable. One thing that I want to point out is don't confuse f parentheses x or g parentheses x or h parentheses x with multiplication. F parentheses x doesn't mean f times x. It means f of x. The x is the input value. Another thing that we need to be careful of is we need to be careful of reading our directions. It says, now let's see how we can go backwards. So make sure when you're looking at these problems that we're looking for what the question is specifically asking. In other words, instead of finding the output values like we just did on those previous 6, we're going to find the input value. In other words, we're given the answer and we kind of need to go back and figure out what the problem is. So in our first function, f of x equals 5x minus 2, it says find x. So we're finding an input value when f of x equals -27. So find where f of x is in our equation. In this particular case, it's here. F of x, negative 27. So we're going to fill in f of x this time. And then we've got 5x minus 2. Now, we knew the output. We want to solve and figure out what the input is. So we're going to solve our equation by adding 2 to both sides. And negative 27 plus 2 is negative 25. But we want to figure out what x is. It's 5 times x, so we have to undo that multiplication, and we're going to divide both sides by 5. And x equals negative 5. G of x equals x squared plus 4. But look at what the problem is asking for. Find x when g of x equals 53. So replace the g of x in this particular problem with the 53. And it equals x squared plus 4. And we want to solve this equation. So we're going to subtract 4 from both sides. And we end up with 49 equals x squared. And some of you probably already know the answer. If you don't know how to solve this equation, what we do is, or what we have to undo is the squaring. And to undo squaring, we take the square root. We square root the right side, then we have to square root the left side, which will give us our answer of x equals 7. If you don't know that, we can pull out our calculator again, and it's going to be second, and then the x squared button. It carries up to use the blue square root symbol above the x squared, and then it's the square root of 49, which gives us 7. I point that out because one more time, find x when h of x equals 6. So this time what we need to do is we need to fill in what h of x equals, and that is 6 equals the square root of 3x. Remember, we just talked about it in the previous problem. To undo squared, we took the square root. So this time, we're going to have to square both sides to be able to solve this problem. And 6 squared is 36. Type it into your calculator if you need to. Squaring and square rooting cancel each other out. This gives us 3x. And once we get that far, then we can divide both sides by 3 to undo that multiplication. And we will get our input, 12. We knew the output. H of x equals 6 was the output. So there's lots of ways to represent functions, and we've been specifically on the front page of our notes looking at equations. But now let's look at some other forms, like the tables is another way of representing functions, or graphs is another way of representing functions. And in this particular example, it says boiling water at 212 degrees Fahrenheit is left in a room that's 65 degrees Fahrenheit, where it begins to cool. Temperature readings are taken each hour and are recorded in the table below. Here, temperature, capital T, is a function of hours, H. So what we have in the top of our chart is we have hours. And what we have in the bottom of our chart is the temperature. And our first problem here says evaluate T of 2. So what that's asking is, and you may or may not decide that you want to write this down, but the question is, what is the temperature at hour 2? So we've got some abbreviation in there, and I can't make that look better, but what is the temperature at hour 2? Well, at hour 2, everything that I wanted was here. That's going to give us our T of 2. We look up at the chart. The top column here of 2, and what we see is below it gives us 104 degrees. Now I don't want to forget here, we also need to find T of 6. So the question then is asking, what is the temperature after 6 hours? Well, we come over here to the 6, and what we see is after 6 hours, the water is 68 degrees. We were given inputs, and we had to figure out the outputs. But it doesn't matter. We can go either direction. Because if we look at Part B says for what value of H is T of H equals 76 degrees. So on Part B, we're giving the output. We're given T of H is 76. So we find that value on this particular chart. There's the 76. And then what hour is it? It's hour 4. And then lastly here on Part C, it says between what 2 consecutive hours will T of H equal 100? Well, the temperature should be a capital T there, but T of H equal 100. Well, between 0 hours and 1 hour, we go from 212 degrees to 141 degrees. Between hours 1 and 2, we go from 141 to 104. Between hours 2 and 3, we go from 104 to 85, and that's what we're looking for. Between what 2 consecutive hours? Somewhere in between hours 2 and 3, we will reach 100. When we finish with hour 3, we'll be less than 100, but beforehand, somewhere in between 2 and 3 hours. We represent functions with equations. We represent functions with tables. We represent functions with graphs. And on example 4, it says y equals f of x is defined by the graph shown below. Answer the following questions. Is f of x a function? And don't do this to your paper, but what we did in previous notes, we did something like that. Does any vertical line ever touch that graph more than once? And it doesn't. And because it does not touch more than once, this is a function. How can we tell? It passes the vertical line test. And you might want to abbreviate VLT. Still looking at the same picture, it is a function. Is this function one-to-one? What you may remember from previous notes is when we're looking at one-to-one, we did this. And the question is, will any horizontal line touch the graph more than once? Well, it does. For instance, here, here, and there. And because a horizontal line will touch that graph more than once, our function is not one-to-one. And the horizontal line test is the reason. And if you prefer, you can write HLT for horizontal line test, like VLT, vertical line test. By the way, 1-to-1 means that no x value can repeat and no y value can repeat either. But let's figure out some values when we know the inputs here. It's evaluate f of 1. Well, we find where x equals 1 on this graph. And we want to find the output, which is where that blue dot is, at 1, 2, 3, 4. F of -1. We did this with equations on the front of the notes, but now f of -1, we find -1 because x is our input, and we want the corresponding y value to go with -1, which is 0. F of 5, f of x. That's what the 5 is. It's an x. It's an input. So we go to 1, 2, 3, 4, 5, and then we find our value here, and that's at 1, 2, 3, -4. And part C continues on, still looking at the same picture, still doing the same thing. Evaluate f of 0. Well, f of 0 is going to be at this pinkish purple point, which is at 1, 2, 3. And if you think about it here, there's a special name for that pinkish purple point. Do you remember what that pinkish purple point's called? Is the y-intercept. Where the graph crosses the y-axis. Whenever x is 0, that's going to be the y-intercept. So now, what value of x, what value or values of x solve the equation f of x equals 0? This is the one that kind of causes trouble sometimes. So I want to point out, again, that f of x is another way of writing y. So we're looking for when y equals 0. And when we do that, on our graph up here, what we're looking at is, and I didn't do very well drawing my line here. Try to draw it a little bit better. And it's not much better. But that represents a horizontal line. And what we're specifically looking at now, because it says what value or values of x solve this equation, we actually already have one right there. And we have another right here, and we have a third right there. So what values are those? Well, it looks like -1 and 3 and 7. And you don't have to have the same order as I do, you just have to have them. -1, 1, 2, 3, 4, 5, 6, 7. Yes. And what special feature are these? Well, when x equals 0, we have a y-intercept. And remember, f of x is another way of writing y. So when y equals 0, these must be x-intercepts. Same kind of thing here on problem number 5. It says evaluate the following. Well, f of 0. Again, 0 is the input. So we go to where 0 is on the graph and we find our corresponding y value, our output, which is 1, 2, 3, 4. F of -3. 1, 2, -3. Go to where x equals -3, find the corresponding y value, and we get -2. F of 4. 1, 2, 3, 4. Go to the corresponding y value, and it's 1, 2, 3, 4, 5. And then again, watch out for what these problems are asking. It says, find the values of x when f of x equals 2. Well, on part B here, with f of x equals 2, Again, f of x is another way of writing y. And what I tried to illustrate in the last example is that y equals 2 is a horizontal line. I'm going to try to use my highlighter this time, which I don't always do. But y equals 2 is here. At least it's straight at that point. Because it says find the values of x. Well, what we want to know in this particular case is, what is that value? What is this value? What is that value? And what is that value? Again, they don't have to be in the same order, but we need to have all of them. -5, -1, +1, and 3. But again, watch out for the questions. What is this asking? And it says, for how many values of x does f of x equals 3? So once again, f of x is a fancy way of writing y. So where y equals 3, and this time it only says for how many values. So if we go back up here, here's y equals 3. And what we're looking for is how many times. There's once. Here's twice. Here's 3 times. You don't have to tell me what they are in this case. It's just 3 values. Will tell us what the input is. 3 different inputs. Lastly, for a function y equals g of x, it's known that g of -2 equals 7. Which of the following points must lie on this graph? Well, remember, -2 is the input. It's the x value of the function. 7 is the output of the function, which is the y, which means that letter C is our multiple choice answer.